Hi, the next piece we're going to do is limiting the player's motion to some room. That was supposed to be, you can only go a certain distance. All right, so let's try to do this. Now, for this, we're not going to really need to add any objects in the scene because this is really going to be done entirely within the script. And every time the player moves, we're going to see, are they staying within the room? All right, so let's take a look. We'll go ahead, open the main script, and we see, okay, each time the player is moving, this is what's going on. So what we could do is, before we actually tell the player, we actually do this motion, we're going to check at this. So the player's going to try to move, and then we're going to clamp that movement to be inside somewhere, some area, perhaps. Okay, so let's say that, let's come up with a little bit of logic, and we'll do this. We'll do it in the first one, our north. Right, so now we have player moved, and we printed the position. So let's see. We want to say if player position, now we know the y is changing. If player position dot y is basically less than some value, or I don't know where that came from, player position dot y is greater than some value, that means they hit a wall, right? Something is going to happen. So let's do this now. So we're going to use some parentheses here to kind of give ourselves the right scope. So we have two conditions. We have player position is y is less than some value, or player position y is greater than some value. We haven't put the value in yet because we don't know what to compare it to. All right, so we need some coordinates. So let's do this. Let's come up here and say, all right, we're keeping track of the coordinates for the player's position and the goal position and so on up here. So let's make the corners of the world. Right, public vector2, and we'll have two corners. We're going to have, now in Unity, we're going to compare to the most and the least here. So the upper right, up and to the right, that's going to be our largest value. So we're going to have an upper right corner, and we're going to need a lower left corner. All right, so these are going to be our corners. We can even put corner. All right, and we can give them some default values. Let's do that. Let's give them some default values. We'll say the first one, I like to cut and paste here. Well, but I won't, just for you, equals, nope, not main text. Upper corner, upper right corner would do something simple. Equals new vector2. And we'll say the upper right corner is going to be 6, 6. Making floating point numbers. Easy enough. And I always like to have, if I'm using initialization, I like to put it on its own line. So we'll keep them separated. So the upper right corner, the highest bounds is going to be 6, 6. And the lower corner, now I am going to cut and paste here, the lower left corner, in this case, we're going to make -6, -6. So we have a lower left and upper right. So upper right would be here, lower left would be down here. All right, so that's where I'm going to be in between. So now I'm going to say, well, okay, if I am greater than the upper right corner dot y, and I'm less than the lower, what happened here? Lower left corner dot y, that means I hit a wall. So I should tell the player that they hit a wall. What's the easiest way to do that? Well, I could add that to the text, the main text. So let's see. In here, I have them changing that position. So I have to be careful. I can't just use it again because it's going to be modified down here. All right, so I need something to tell them that they hit a wall. So let's see. I could use a Boolean condition. Let's try this. So up here, we're going to say bool hit wall. And we're going to start off with it being initialized to false. So in here, we can say, well, okay, hit wall equals true, right? If this happened, it means they hit the wall. So down in here, now I know them hitting a wall isn't something that's going to happen as a result of finding the goal. So I probably, in this my default case here, I said you moved, but it is dark. And we can say if hit wall, we're going to add something to our message. And adding to a message means plus equals, and we're going to put a new line and say, oh, I lost our quote there. We're going to say, you hit a wall. All right, so if we wander around and we smash into the wall up here, it's going to say we hit the wall. Save that. Let's come back over here and see if it worked. Now we only checked it in the go north condition. So let's keep that in mind. So we're gonna hit play, and we're gonna go north. You moved, but it is dark. And our position is 4, our position is 5, our position is 6. That's still within the world, our upper corner here. We hit 7, you hit a wall. If we keep going, it's just gonna let us go in that direction. If I go south, look. I moved, but it is dark. Why? Well, because hit a wall wasn't set anymore. Because I'm moving outside that, which is kind of weird because it let me go outside of range, and then now I was moving back in and it wasn't checking that anymore, which is slightly odd, right? So let's stop and let's fix our logic, right? We have the basics there where we're saying, okay, we have a wall, and it's defined by that rectangle, 6, 6, -6, -6. So we're off to a good start. However, we're not quite there yet because we're checking to hit a wall here. So next we also need to check hit a wall here, right? Whoops, don't think I copied enough there. There we go. So here's what I wanted to copy and put down in here. So now we'll check, it's the same check in here for the north and south. And down here we want to check it, well, for west and east. So that means I'm now going to check X. And player position to lower left position X. And upper right corner X. And we'll do the same thing there. And we'll also do the same thing here. Now, as you'll notice, there's a lot of shared code. So this is a good circumstance. Let's see that it works first. And you'll notice if I can make if I have a bug in here, if I forget, if I may leave this one player position Y, and this is, I could potentially run into some problems here. So let's first check if that works. We'll do that first. And then we'll refactor that into a little function. So we're a subroutine in this case. It's going to be sort of a function or a subroutine. So we'll press play, and we'll go north. We'll hit our world. Ready? 7. Boom, I hit a wall. If I continue going and now go south, it says, it's still hitting a wall because I'm inside the wall somehow, or I'm in that stone. I'm outside. It's a bad place to be. I move inside again. Okay, now it's all right. I move to the south. I'm going to hit -6, -7. Boom, I hit a wall again. Go west. Boom, I hit a wall. Go east. All right, now I'm in the world. Boom, I hit a wall. All right. So I have the message for hitting a wall, but I'm still allowing the user to wander off and smack into things, which isn't great. So rather than continue down this path of having our code in each one of these loops get bigger and bigger and crazier, this is a good idea now to say, all right, let's create a subroutine, right? And this isn't going to be public since we're not going to call this from any other functions. This is just going to be a void, and it's going to be update position. Okay. Or even update player position specifically. And we're going to take, we'll go ahead, we'll take this one. We see that we're kind of following the same thing. We're always printing out the position, and then we're checking to see if they hit the wall, right? And doing something down here if they hit the wall. So we could just do this. We could say there's no harm sort of in putting the check for, whoops, update. There's no harm in checking both the X and the Y every time the player moves, right? So now we have the check for the player X and the player Y, so that we can combine those two things, and this print position. So let's grab this whole code and make that our player update. So let's put player, update player. Oh, what's going on here? Void. I got a bunch of things going on here. Update player position. All right. Now we're doing something interesting, but there's potentially some issues here, right? Our code down here is saying, okay, this is where we tell the player where they hit the wall or not. So how do we communicate back to the player? Let's do it for each one of these now. How do we communicate back to the player or to this routine that a wall was hit? Well, let's do this. This is going to be easy. We're going to say, instead of a void, we're going to say this function passes back a bool. And we're going to say to return true if it hit the wall. And notice it's complaining. It's saying, not all code paths return a value. So back down here, we should say, okay, return false. So that if either of these don't happen, false is returned, and it means we didn't hit a wall. So we can say, now, hit wall equals update player position. And we should do this really for each of them. Now what's going on here? Oh, I accidentally took out the break. Okay, now we're getting interesting because now we can say, all right, after the player's position is changed, we can update the player's position on the screen according to that. So that should work, and it's a little bit cleaner now because we're putting some code in here together. All right, so come back over here, and hopefully everything still works. I always have to hit play twice there. So we'll go north, hit the wall, go south, and eventually we're not hitting the wall, go west, and we hit the wall, and so on. And we hit the wall over there. All right, life is a little bit simpler because now I don't have to change the same code 4 times. Now I can just change it here and update player position. So what I need to do, if I see that the player's position has gone out of the boundaries, I don't want to let the player go through the wall. So I need to clamp the player's position, right? So I can say player position.y. I need to modify it. I'm saying it's outside of the range that it should be allowed to be in. So player position.y equals, now I'm going to use my mathf, which we talked about in class, dot clamp. And the value we're going to pass in is player position.y. Right? Player position.y. And the minimum and maximum that is allowable. Okay. So the minimum and maximum that is allowable is actually within lower left corner and upper right corner, right? So we're going to say lower left corner dot y, and what would be above that? So we'll say +1. Right? Returns the given value if it is within the range. Let's see. Actually, let's demonstrate and see the potential issues. If we just said lower left corner and upper right corner. Let's check. Is this inclusive, is what we say. So is it going to mean it's going to be inside this range or up until the edge of that range? And we do the same thing down here. We're going to say player position X and clamp that to be within our area. So let's see. Okay. Is it going to keep us in that range, or is it going to let us come right up into the wall and be at the wall? And that's sort of up to you. I mean, I guess that would still be a workable game. It would still play correctly. But it's sort of a question of your intent. Do you want to let them go right up to the edge of the range, or do you want to let them outside? So you see, like here, I got to 7, and it stopped me. But let's see. I'll go over here, and let's look at the actual position that we're at. So in main, all right, player position is actually at 0, -6. It's not at that. That's what was reported before it got clamped. Before it got clamped. So that's potentially a bug, right? It's reporting this value, but it is clamped and keeping it within that range. You see upper right, lower right, so it can get to 6, but it's showing that. All right, so we need to fix that. All right, so it's okay. We're going to let the player get to 6, 6, -6, -6. All right, so that part really worked. We didn't have to change that. But why? So why is it having that issue printing the position? And it's because it's because the position is reported up here before we clamped it. Right? So it's before we clamped it, and that's potentially the problem. So the question is, can we just put it after we clamped it? And that potentially works because we already printed it once the last time around, but I suppose it's a little bit wonky that way. So let's take this out, and let's only do this for now to say after we've clamped, print the position. And after we clamped it here, print the position. Just in case that didn't happen or that didn't happen, right? We have to print it out there. And then there. Right? So this is potentially a little bit weird because why? Well, there's multiple paths that return, and we have to make sure this is set before we return. So we could even go back to, maybe this is a good case to say, to have a local variable called bool hit wall. All right. And let's initialize it to false, just like we did in the other one. We're going to assume we didn't hit the wall. So let's go in here and say hit wall equals true if that happened. And hit wall equals true. And if so, we'll get rid of the return here, and we will return hit wall. So now our code is going to execute through here, and we don't actually need this extra bits of the print position anymore because it'll go through and hit wall will be true, and it'll work the right way. It will clamp if it needs to, and actually the clamp would even be possible outside there if we wanted to, because the clamping is always just keeping it in range. So let's leave it up there. So it's going to be check if y is out of range, hit wall is true, and clamp it. If x is out of range, hit wall is true, and clamp it. And then print out the position and return whether or not you hit the wall. All right. So now the player's position should be reported correctly because it's not done before we actually modify the value. You always want the position to be updated after the potential modification. You want to just see, it's like basically saying, okay, whatever's on the screen should really reflect the proper state. Right? That's why normally rendering is done as the last thing that we do. All right, so now we have it doing hopefully the right thing. So let's see our main routine over here, and we're going to go up and hit a wall. And notice we can't get past 6. All right. We have constrained the player to an area. Congratulations, that's part 2.